Okay, so now we're up to k closest points to origin. Let's get this set up over here and over here. This is 973. Zero 973. K closest points to origin. Grab this. Oops, just that part. I'll say pub struct solution. Paste that in, back new. Make sure it still builds. Okay. Given an array of points, where points of I is equal to x sub I, y sub I represents a point on the xy plane and an integer k, return the k closest points to the origin 0, 0. Distance between 2 points on the xy plane is the Euclidean distance, square root of the difference of the x's plus the difference of the y's squared. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. Okay. The reason I'm hesitating is because I don't have any code that can check vectors in any order yet. Maybe I should add something like that. But let's start with this one because example 1 just has a single entry as its result. If we use this for our test, this sounds really straightforward. You just loop over all the entries, insert the distance into a vector, sort the vector, and then grab the k entries from the front of the vector and return those. Right? Solution. K closest. Vec bang. Paste. Close that. Change this to a 1. I mean to a thing without the k. Put a vec bang here. Put a vec bang there. And then the actual should be vec bang minus 2, 2. And somehow I messed this up. Oh, like that. There. Okay. So, yeah, I mean, it should just be, we can calculate the closest values. Let mut dist equal vec new for p in points. We can consume it, right? We don't need to worry about that. And we can say dist.push. And then points is just, it's a vec 32, but there's just 0 and 1. Right? And so we just say p of 0. Oh, we need square root. And the one thing I remember from Rust earlier is that square root is only on the F32, F64, which is fine. Let's just use that. We can cast the values. There's no I square root in Rust. Yeah, that was the other thing. So it's just the squares of the x values plus the squares of the y values. We don't, I don't need to parenthesize that because I'm going to do square root. P1 times P1. But we want this as F32. So I do need to wrap this whole thing here. Or F64. Right? Let's do F64. And then do square root. And that gives us the values. Now we say sort, dist, sort, reversed sort. So we have to do a sort by. And I can't remember if, is it b dot compare a? B dot compare a. And I know I need a reference in there somewhere. Right, and then we just say to return the vector of vectors. Oh, we need the actual points. Oh, let's just println. Let's see if we get it right. Dist. And then we can just return vecnew. Oops. I put a semi there. Uh-oh. Oh, right. With floats, you have to do partial compare. Option. Unwrap. All right, so it found 2 points. And it's in saying the second point is the closer one, which is correct, right? This is 1.36 distance. And this is 2.82 distant, 2.83 distant. And so it would return that one if we could remember that. So that means we need to not just push the square root, but we also have to push the point. And maybe we can do that as a tuple. Yeah, so now we have the tuple, or not the tuple, but we have the vec. Okay. Then we want to, I guess, iter take. Let values is equal to dist iter take k. And then map the entry into just e.0. Collect vec of I32. I don't know, I'm going crazy here, aren't I? And we can println val. Oh, but this doesn't work. I missed a closing bracket, closing angle. Expected use size found I3. Okay. Oh, okay. That's annoying. We can't just take it out of there. And okay, now we need to actually reference. All right, so it found 1, 3, and it found 2, 2. And we want the, we want the closest. I have this backwards. I have the sort backwards. B should be A, and A should be B. Yeah, and then it returns this. Okay. So it gets a val here. And I think we can do a bunch of cleanup. All right, that did the trick. And then let's take a look at the second example, because now it's going to return multiple points. It's going to return 2 points to be specific. So test ex2. That's 4 lines yanked. And then we'll just do this, paste, comma 2. And put in the vex. And then this should be 3, 3, and vec bang -2, 4. All right. Does that pass? No, it doesn't. Oh, I forgot a comma again. Yeah, okay, so this is where things get messed up, is that I need to be able to compare the arrays in the correct order. We can switch these around since we know that this one is bigger than this one. We can just do that for our test purposes. And then get our test to pass. Okay, I think we can clean this up a bit though. We should be able to use instead of doing it for p and points, we should be able to say points dot iter dot map p, and then just use this. Right, and then say collect that into the thing we wanted, which is a vec of a tuple of vec I32 comma F64. Yeah, and that gets rid of that. It does have to be mutable because we need to sort it. Oh, can I do that? Ah, okay. Clone. Okay, and that passes. We can get rid of this print here, and we can get rid of this here. And then instead of doing this, we can just say this, right? Without the semicolon at the end. Yeah, okay, so that's a little bit cleaner, right? All we did was merge everything together. Let's copy and paste that. And see if that does the trick. Uh-oh, found one. Found one it didn't like. Okay. Let's try to reproduce it. I wonder how many it actually got through. It doesn't tell you that, does it? Let's paste this here, and then insert EQ, solution, K close est, vec bang, comma 2, that's this 2 here, comma, and we're expecting these guys. Copy. Paste. Vec bang. Yeah, like that. Okay. Yeah. Okay, so we need to now print this out and find out what we did wrong here. Print lin dist. Oh, wait. This isn't sorted correctly, is it? Oh! These, oh, that's why. Yeah, we want to sort by dot one. So it's a dot one dot partial compare b dot one. I wonder how it was comparing the tuples. Reference. Yeah, and now this is backwards. That's fine. We can fix that. I need to write a little bit of code that'll do that. It was this one, right? Okay, 3.3. Yeah, okay. So now let's try this solution. Get rid of the print. I think it was just this one line I changed, right? I don't like how it consumes the new line. There we go. 109 milliseconds. It's still slow. I don't know how you can do it faster. I mean, you're basically iterating. I guess this is the only thing that's going to slow it down is you're allocating a new value there each time. So I guess another option would be, no, you still, oh, Sebastian points out that the square root is not necessary. That's true. That's absolutely true. Let's see if that saves any time. Because then we're not even dealing with, oh, let me do it over here because I'm going to mess up some parentheses somewhere. The only thing is that this squaring these things is going to end up as, might blow through the I-32, depending on what the numbers are. Let's find out. And the three tests pass. And then we don't have to do partial compare. We can do full compare. Right? Without the unwrap. Zero cost abstractions though, right? Okay. Let's see if this works. But I'm thinking there might be one or two tests which this will overflow the I-32. Let's find out. Oh, I guess it would have already overflowed from before. Yeah, now we're down to 38 milliseconds without having to do the square root and the float conversion and the float comparison and all that kind of stuff. Yeah, thank you, Sebastian. That helped. And now we're faster than 97%. All right, let's make that our official git add source. Git commit -m problem 973. K closest points to origin. And